So we got our real number line, we got our imaginary number line, we've got numbers that can be written in rectangular form. They are in the form a plus bi. Polar form is a little bit more complicated. Z equals r parentheses cosine theta plus I sine theta. And in polar form, we do have stipulations on our theta. It cannot be a negative angle. It must be something between 0 and 360. So let's look at number 2. So number 2 is giving us the complex number z is equal to 3i. And what's the first part of the directions asking us to do? What's the first verb you see up there? Plot. What's another name for plot? Graph. Like at first I'm thinking plot. I mean, it's like we're English or something, and we're in England and they've asked us to plot the point instead of graph the point. I don't know why they said plot. It means graph. It is a Z. Miss Haynes, my Algebra 1 teacher, way back in like 1981, she always put a line through her Z so it didn't turn into 2's. And so I got that from her. All right, so remember your horizontal axis is going to be your real axis and your vertical axis is going to be your imaginary axis. And so when we think about this number, some of you may have to do this to begin with until you realize what we're doing. But when we think about this number, the real part of this number is 0. It's understood. The real part of the complex number 3i is 0. And the imaginary part is positive 3i. So when we go to graph the complex number in its rectangular form, it's like graphing an XY point, but we're graphing an A, comma, B point. All right? So same concept. What's the A value of this point? All right, 0. So if we go back and look at this, the A part is the real part, the B part is the imaginary part. So the A part would be 0 and the B part would just be the 3 part. A is the real part, B is the coefficient of your imaginary unit I. And you won't do this when you start graphing. These will be so easy to graph, but I'm just trying to go through some of the notes with you so you have them to look at. So if we're graphing A, comma, B, which is really 0, comma, 3, which is really 0 on the real number line and 3 on the imaginary number line, we're just going up 3. Yeah, it's that simple. Okay, so we're going to plot, because we're in England, we're going to plot the point, and then we're going to find the absolute value. Then we're going to find the absolute value. Okay? Absolute value is the distance, it doesn't tell you this, but the absolute value is the distance from the origin to the point that you have plotted. Okay? Absolute value is the distance between the origin and the point that you have plotted. Maybe you want to write that down. Absolute value is the distance from the origin to the point that you have plotted. Some points we can just count the absolute value, like this one. So what's the distance between the origin and the point that we have plotted? 3. And we do have a little symbol. You know, if we were finding the absolute value, we would do absolute value. And the absolute value of our complex number, again, is the distance between the origin and the point that you have plotted. So in this case, it is just going to be 3 units. They do get a little bit more complicated. If the distance is diagonal, we'll have to do a little math to find that. But if your point is on any of the axes, then you just count to find the absolute value. All right, any questions about 2? All right, we're going to speed up a little bit. Number 6, same set of directions, plot the point, find the absolute value. So here's the point, 2 plus 5i. We're going to skip a little bit of that work, okay? If we're plotting 2 plus 5i, we're going to draw our imaginary number line and our real number line. You don't have to label those as long as you know the horizontal axis is the real number line and the vertical axis is the imaginary number line. We're going to travel to the right 2 and up 5 to plot our point. Now, sometimes I don't understand just because I've done this type of math a lot. I don't understand when something's difficult, when something's not, sometimes. I had a chemistry teacher like that, and I never asked a question because every question I asked, she looked at me like I was a complete idiot. So I just stopped asking questions. Okay? So does that make sense to you? The A value is 2. The B value is 5. You go 2 units to the right on the real axis, and you go up 5 units on the imaginary axis. Does that make sense? Is that easy, hard? I need some type of indicator. Okay, now, when they're asking us for the absolute value, again, that's the distance from the origin to the point that you have plotted. I can't just count this time because that's actually a diagonal distance. Okay? So there is a little formula that we can use when you can't just count. And if you'll think about it, we have a right triangle. So I'm just going to draw in the right triangle just to show you that I've not made this up. But this distance that we're looking for would be the hypotenuse. And then we could draw in the 2 legs. And we would actually have a little right triangle there. So what would be the length of the horizontal leg? 2. And the vertical leg? 5. So we could just do a little Pythagorean theorem here. And to find the distance between the origin and that complex number point that we plotted, we're just going to do 2 squared plus 5 squared equals the absolute value squared, and then we'd end up having to take the square root. So really you're just doing square root of your a squared plus your b squared. And you won't write a squared plus b squared every single time, but your a is your horizontal distance, that's the real number, and your b is that vertical distance. You'll probably just skip that step, and you'll do 2 squared is 4, 5 squared is 25, and so the absolute value or the distance between the origin and your complex number point that we plotted would be the square root of 29. Okay, so if your complex number is not on an axis, you'll have to actually use the Pythagorean theorem. That's what we're doing there. All right, let's look at number 10. Number 10, still in the same set of directions. Z is equal to negative 3 minus 4i. Negative 3 minus 4i. Got our little imaginary axis and our real axis. We're going to travel on the real axis first, and we're going to go to the left 3. And then we're going to go on the imaginary axis, we're going to go down 4. No reason to have graph paper here. You can just plot your little graph, just draw your little lines. And then hopefully if you really understand what you're doing, the next step it says, hey, find the absolute value of that point. That's the same thing as the distance between the origin and your point. And you'll just break out in a quick little Pythagorean theorem. Is that rain? How long has it been since we've heard the rain? Oh my gosh. Go. Go. Let me see if I have an umbrella.
No, it's okay. I live on driver
Umbrella.
I'm good.
With an umbrella. Run fast. We're thinking about you. Run, Joseph, run. Okay.
He's going to close his window.
His windows were down and it's raining. Where were you, Thomas?
I didn't know where he was going. I know it was raining.
Okay. I'm sorry. I'm such a smart aleck. All right. So our horizontal leg would have a length of 3, and our vertical leg would have a length of 4, and 3 squared plus 4 squared. You can do that in your head if you want to. You can write it down. Y'all are to that point. That would be 9 plus 16, which is 25, and the absolute value, or the distance between the origin and your point, is 5. Now, when they say absolute value, that doesn't just set off a bell that this is distance, but that's what they're asking you for. Okay? If they're asking you to plot a complex number and find the absolute value in this context means distance. Okay? Any questions about those examples? Freaks and change directions. All right. Last set of directions. These go with problems 11 through 26. And the directions say plot again. Plot each complex number. Plot each complex number, then write, this is the harder part, then write the complex number in polar form. All those pretty leaves are getting wet. I was noticing this morning when I drove out of my driveway what pretty leaves are on the ground. Fall is one of my favorite times of the year. Then write the complex number in polar form. All right, number 12. All right, so in the second set of directions, there's only 2 set of directions for tonight's assignment. They're going to ask you to plot the complex number. We've already gone over that. Then write the complex number in polar form. We'll have to talk about the polar form. All right, so the square root of 3, in order to plot the square root of 3, I need an estimated decimal to the 10th for the square root of 3. Anybody have that memorized? 1 point something. Great job. Somebody estimate 1 point what? All right, so we would have to get an estimate for the square root of 3 because we're not robots and we cannot exactly graph the square root of 3. So we get an estimate for that. So we're going to move to the right one, and we're going to move up at about 1.7. To the right one and up about 1.7. So you'll just kind of estimate that. Now, the reason they're making you graph here is because you have to make a conscious mental decision on what quadrant you're in. Because when we go to polar form, you're going to have to find the angle of rotation that will get you to that point. And if you're not thinking about, am I in the right quadrant, you're just going to punch this stuff into the calculator. You're going to use your knowledge about the unit circle, and you may not get the correct angle. So what quadrant, when we get done with this problem, what quadrant should theta be in? Quadrant 1, because your point is in quadrant 1. That's why they're making you graph. There's really no reason to graph here other than they know you're just learning. Wow, you are so fast.
I got out there and sprinted because it was a lot farther down than I thought. So.
Oh, me. Goodness gracious.
That was fun. Yeah.
I bet you're awake now. We should all get up and run.
It's soaked. Yeah.
Okay, so in order, y'all hang with me. In order to write something in polar form, we have to know what R and theta is, okay? In order to write something in polar form, we need to know what R and theta is. So y'all been with me long enough. Y'all know I like to go ahead and get organized here. If we're going to have to write something in polar form, those are the 2 things that we have to know, okay? So how do we find the radius? So the radius, it goes back to that triangle. Okay, it goes back to your triangle. Here's the radius. Here's your point. Okay, I'm just pulling that out of that diagram. The radius would be the absolute value, the distance between the origin and your point. The horizontal distance is A, and the vertical distance, since these are complex numbers, is B. So again, we're just using the Pythagorean theorem to find your R. So to find your r, you're going to use r squared is equal to a squared plus b squared. And to find your theta, you're going to use tangent of theta is equal to, we don't have x's and y's anymore. We have a's and b's and z's, but z's doesn't have anything to do with theta. So there we go. Mary Arlen's so smart. We don't use y over x with complex numbers. They use a's and b's, so we use b over a. Good job. Girls rule and boys drool. All right, so that's all you need. R squared is equal to a squared plus b squared, and then we'll take the tangent of the theta that we're looking for, and we can turn that into the b value divided by the a value. We just got to make sure we're in the right quadrant, and then we'll plug all that into that complex form. So let's find our r. So we know that r squared is equal to all that, so I just jump right in to say r squared is equal to our a value squared, so that'd be 1 squared plus the square root of 3 squared, and that would end up being the square root of 4, which would end up being 2. And I realize some of you will do a lot of work to find the radius. Some of you won't do any work to find the radius. I know that by this time, and I know some of you really, really well. I know how many of you need to write it down. I know how many of you don't and should, and all that kind of good stuff. All right, let's do our theta. Let's find the angle of rotation to that point because we're going to polar form. So our b value is what? Square root of 3 over our a value, which is 1. So that means our tangent of theta is the square root of 3. Now this is where we have to say, do we pick up our calculator or do we use our unit circle? Okay? If we recognize the tangent value, and remember there's tangent values of 1 and -1 and square root of 3 and negative square root of 3 and negative square root of 3 over 3 and positive square root of 3 over 3, 0 and undefined, those are all the tangent values on the unit circle. So think about what angle in what quadrant? In the first quadrant has a tangent value of square root of 3. 60 degrees. If you were feeling radian-ish, you might say pi over 3. Okay, so you were feeling like you were wanting to do in degrees today, so you say 60 degrees. So now we know r is 2 and theta is 60. And now we can go into polar form, which is a little bit complicated. Everybody know where I found the r and the theta. I'm going to erase just so I can kind of put it right here. So everybody understand how we find the radius and how we find theta. All right, I'm erasing. All right, let me connect something to your prior knowledge, if you have any prior knowledge. So prior knowledge says that x is equal to what? With the r in it. R cosine of theta. And our prior knowledge says that y is equal to r sine theta. But we're dealing with complex numbers, which are not x's and y's, but a's and b's. So technically that still applies. So a is going to be equal to r cosine of theta, because a and x are technically the same thing here. And b is going to be equal to r sine of theta. So what you're going to do is you're going to take your complex number. You'll put a z there, just because we're going to end up with a z equals. And your complex number is 1 plus I square root of 3. Your complex number is 1 plus I square root of 3. And in the place of your a value, what's your a value right now? What's your a value? 1. So in place of your a value, you're going to put in r, which is 2 cosine theta. Now this is really, really weird, but in the place of your a, which is the 1, you're going to replace that with r cosine theta. You're going to keep the I, and square root of 3 represents what value? Square root of 3 represents your b value. And in the place of your b value, the I comes down, but in place of the b value, you're going to put in r sine of theta. So you're going to put in 2 sine of 60 degrees. Did I lose anybody?
Kind of.
Okay. The I stays because this is a complex number. And then your last step is to realize that the radius is in both terms. You see the 2 in both terms. And so you'll just factor out the 2. And you'll get 2 outside the parentheses, so you'll have cosine of 60 plus, sometimes they put the I in front, some they put the I at the end, it really doesn't matter. And then you'll have I sine of 60 degrees. And that's that same complex number in polar form. Questions? You know it gets easier as we do a few more. First time it's like, oh, that looks awful. Looks pretty bad. That's the answer in polar form.
We don't need to simplify the cosine.
You actually just leave it with the radius and the theta in there. It looks useless, right? Okay. So you're converting a complex number, which is 1 plus I squared of 3. You're converting it into polar form. So take a look. Okay, look at what's in yellow here. That's what they call rectangular. This is a little bit different because we've not done complex numbers. That's what a complex number looks like in rectangular form. And then this is what a complex number looks like in polar form. Both of them say z equals. One is in the form where it has a plus bi. And in the polar form, you'll always have the radius where the 2 is. The radius will always be outside. And some of y'all start to do some shortcuts, and you'll skip that middle work that I did. And then you'll have cosine of an angle plus I sine of an angle. It looks like that every single time. Questions? All right, let's do a few where I know the angles are going to cause you trouble. So I picked a few things where we need to consider the angles and what makes these problems a little bit harder. All right, so if they give you the complex number 2 minus 2i, remember the first part of the direction said plot. Said plot. So they give you the complex number 2 minus 2i. We're going to go to the right 2 on the real number line and down 2 on the imaginary number line. And the only reason they're making you plot right here is because they are trying to make you realize that you have to think about what quadrant your original complex number is in. Because some of you won't ever think of it. You never thought about it on the last test, ever. You just punched the stuff in your calculator and wrote down the number. Never once thought about whether you were in the right quadrant or not. Because I don't think you really understood what you were doing when you were converting your XY point to polar form. I don't think it ever... No. And after you do this project, you might figure it out when you're graphing Elmo, and Elmo's I is supposed to be over here, and you got it down here, and you go, oh, that's the wrong angle. I'm supposed to add 180. Okay? All right, so if we're going to put this in polar form, we need to know r and theta. So real quick, over to the side, r is going to be the square root of what? 4. You sure? 2 squared plus negative 2 squared. If you can't do it in your head, write it down. That's going to be the square root of 8, which simplifies to be 2 square root of 2. All right? So I don't care how you find the radius, as long as you can find it. Some of you, again, may need work. Some of you may not. Now we got to find theta. To find theta, we've got to use tangent, because tangent involves the b and the a. So we're going to say tangent of theta equals b divided by a. And you'll start skipping that step, and then you'll just write negative 2 is your b value over a, which is positive 2. And you'll simplify that out. Negative 2 divided by 2 is really negative 1. So can I use my unit circle to find this theta? Yes, I do have tangent values where the y divided by the x is a negative 1. I've got to find that angle that's in the 4th quadrant. 315, he just said that? Nobody wanted to say negative 45 degrees? Anybody think negative 45 degrees?
No.
Anybody think negative pi over 4?
No.
Nobody? Okay, that's where I'm getting at. But did anybody think of that? I would have thought negative pi over 4. Negative 45 degrees. That's what I would have thought first. Nobody else?
No.
You would have thought 315? Okay, so if there's anybody out there that's not being honest to say that you might think of a negative angle, because the calculator would give you a negative angle if you did this, okay? If you happen to think of negative 45, then you would just have to add 360 to it, okay? Because we're in the right place, right? We just need a positive angle. So we're finding a coterminal angle there just by adding 360. We add 180 when we're in the wrong quadrant. So if you happen to have thought negative 45, you just add 360 to it to get to that same point that's positive. We don't have the wrong angle. That one just happened to be negative. Okay? So if you thought of 315, awesome. I would have thought of the negative one. All right? So real quick, into polar form. So we have, our number was 2 minus 2i. So into the A, we put in r cosine theta. And for the B, we put in r sine of theta. Into the A, r cosine of theta. Into the B, r sine of theta. So into that first positive 2 there, we put in r, which is 2 square root of 2 cosine of 315. Seems really weird, but we know that the A value is equal to r cosine theta. So that's what allows us to substitute that into the place of the 2. We bring down the I. The I has to stay there. It doesn't go anywhere. And then in place of the negative 2, because that's your B value, you put in r sine of theta. In place of the B value, you put in r sine of theta. So that goes 2 square root of 2. Sine of 315. Last step will be to factor out your radius, which is 2 square root of 2. And then you're left with cosine 315 plus I sine 315. Doesn't look like you're finished, but that's polar form. Radius will always be out on the left-hand side, and then you'll have big parentheses. You always have cosine first of an angle plus I sine of the same angle. All right, real quick, let's look at number 20. 20 will be quick because it's plotted on the,
Miss Craig,
yes.
on the last one, is it plus sine 315?
It's always a plus. Good question, because that seems weird, but you're replacing the B value. So you're replacing the negative 2, that's your B value. You're replacing that with r sine of theta, which will always be positive because your radius will always be positive. I know that's a little bit weird. All right, number 20, here's your complex number. Did you know that complex numbers have real parts and imaginary parts? This one just doesn't have an imaginary part. So it actually seems weird to us because we've already been so involved in the complex numbers. So how would you graph negative 4? You would go to the left 4 on the real number line. See, y'all have already forgotten how to do everything in the real set. There's no imaginary part to this number, which is now confusing, but there it is. All right, I need to find r and theta. This one's going to be really quick, no work at all. Please tell me you can find the radius there. 4. Please tell me that you can find the angle of rotation. I'll draw it in for you. 180 or pi. Let's use a radian this time just to show we can. Okay, you could do 180 degrees there, but let's just put a pi there. So we didn't have to use any math to find the radius because the distance was on a horizontal axis and we could just count. We could also look to see the angle of rotation was pi or 180. And then let's plug that in. So it might help you to realize that you have a 0i. So your complex number is -4 plus 0i. So into your -4, you're going to put in r cosine theta. So that's going to look like 4 cosine pi. So in the place of A is equal to r cosine theta. A is the -4, so you're going to put in its place 4 cosine theta. You're always going to put a plus. Good question a while ago. And your B value is 0, and in the place of that 0, you're going to put in r sine of theta. You're still going to have the I, and you're going to put in r, which is 4, sine of theta. Last step, since both terms have a 4, they'll factor the 4 out, so the radius comes out on the left-hand side, and you're left with cosine pi. Just in case the book reverses this, I'll show you it's okay to have sine pi I. I honestly can't remember which way you write it. It doesn't matter because we're multiplying those together. I like to write it last. Sometimes the book writes it first. I actually can't remember, but you could see the I in front of the sine or behind it. All right, so we're almost out of time. Questions? Okay, I want to talk about one thing really quick. I had a couple more examples. I'm not going to get there. What if your theta is not in the right quadrant? What if it's not in the right quadrant? You're going to add 180. If your theta is not in the correct quadrant where your point is plot, you're going to add 180. If your angle is in the right quadrant, but it is just negative, we're going to add 360, just because we know in polar form our angles have to be positive. So that can be a little bit tricky.